Now let us try to solve a few problems on this case one, that is a cantilever subjected to concentrated loads. Okay, now let's just go down. When we go down here, we see we have two problems. In these problems, what do we see? We see a cantilever beam subjected to a load of 10 kilonewtons. It is at a distance of how much? It is at a distance of 5 meters, okay, from the support. Now let's try to draw a bending moment and shear force diagram. So space is very less. Let us just try to do it out over here. So what is the shear force at A? If I want to draw shear force now, first of all, what I need to do, I need to make the sign convention. Just let me draw. This is my x-axis. Anything on the right side of x-axis downward is what? Positive. Left side upward is positive. Okay. This is negative, and here this is negative. And upward bending moments are always positive. Downward bending moments are always negative, irrespective of left side or right side of the section. Okay. So now let us see. If I take this one, if this beam, if I am taking my section over here at any point, let us say at this point or any point, if I take, see, support is here, is it not? So what I will do, I will just make the section over here. If I make the section over here, where is my force 10? My force 10 is on the left side of the section, isn't it? Left side of the section, downward is what? Downward is negative. So let me change the color. So what I will do, shear force between A and B, between A and B, that is F of AB is how much? Minus, because left side of x-axis, see the sign convention, downward is minus 10 kilonewton. So what can I do? I have to draw a sketch over here. Let me make the sketch separately because this is too big here and there is no space. So if I have the beam over here like this, if this is 10 kilonewton, just make lines like this. Downward is how much? 10 kilonewton. 10 kilonewton. This is a minus sign. Minus sign is indicating what? Minus sign is indicating the direction. This is your shear force diagram. Now let's go to bending moment. Bending moment. So what would be the value of bending moment now? What is bending moment at A? Bending moment at A is equal to force. Force is what? Force is 10 kilonewton. What is the distance? 0. That is 0. So bending moment will be, if I draw a bending moment diagram at this point, it is 0. That is M of A is equal to 0. Now let us go at B, because this was A, this is B, is it not? So bending moment at B. Bending moment at B will be how much? M B is equal to force. Force is how much? 10 kilonewton multiplied by distance is how much? 5. It is trying to bend the beam downward like this, is it not? See here, sign convention, downward bending moment is what? Negative, is it not? That is minus 50 kilonewton meter. What it is? It is a straight line. Minus 50 kilonewton meter. This is your bending moment. Understand? Shear force diagram. This is bending moment diagram. Okay, fine. So this is for this problem. Now let's go to the next problem. In the next problem, what he is having now, if I take this one as my xx, I will take this one as xx. Now see, where are my forces? It is on the right side of my reference plane, is it not? So here, right side of reference plane, downward force is positive, upward force is negative. Okay. So if I want to draw, if I want to make the shear force, so what I will do, first I will find shear force between A and C, between A and C is equal to how much that is. If I keep my line here, I am talking about the right side, okay, this side. So this side it is how much? Plus 5 minus, and plus 5 only, okay, plus 5. So this is how much? This is kilo Newton. So if I want to draw this sketch, how does this sketch comes now? First, let me make this sketch here. So I'm making a separate sketch. This is 5 kilonewton. This is A, this is B, and C is somewhere over here, is it not? So if I want to draw, okay. So between A and C, it is how much? Between A and C, this is, sorry, I made it wrong. I have to do it upward. Let me just do it. Wait a minute. Okay. It is how much? I have to draw a line here. Positive, is it not? Because right side downward is plus 5. So I have over here. Now let me go shear force between B and C. That is what I am doing. I am just coming at this point. When I come this point, the whole thing will come into picture. The whole thing will come into picture. Okay. So it becomes how much now? Plus 5. Right side upward is what? Right side upward is C. Right side upward is negative, is it not? Minus 2. That becomes how much? Plus 3 kilo Newton. So from 5, I am coming down to how much? Plus 3. It comes down here like this. Okay. This is my shear force diagram. This is plus 3. Okay. Now I need to do what? I need to do bending moment also. Okay. So now let me write bending moment here. Unfortunately, there is no space in this presentation. Let me write bending moment. So bending moment at A, M of A is equal to how much? Force into distance. At this point, there is no distance because you are at A only. So I will write 5 into 0, that is 0. Bending moment at C, sorry, bending moment at C, let me erase this. Bending moment at C is MC is equal to how much? 5 multiplied by 4. Since it is trying to bend the beam downward like this, it is negative. That becomes how much? 20 kilonewton meter. So it is in what direction? Minus, is it not? So now first I will just draw a line here like this, and then you have what? You have 0, then you have minus 20. Now let me go to the last one. I'll just change the color for the sake of identification. Bending moment at B, that is M B is equal to how much? You have minus of 5 into Arba Zayed Wahed is Khamsa. Then Zaid, why this force, this 2 kilonewton is trying to bend the beam up, is it not? So it is positive. See, upward bending moments are what? Positive. Downward bending moments are what? Negative. This is bending moment, is it not? So plus 2 into 1. This gives me how much? Minus 25 plus 2. That is minus 23. So you have 20 and then 23 here. It is also a straight line. Minus 23. This is kilonewton meter. See, this is the bending moment diagram for these two cases. Okay.